Hi, everybody. In today's video, we are going to talk about something called solving proportions. There's two different methods that I'm going to show you, and depending on the problem, you can kind of use either method. So a proportion, just to clarify or to let you know, is when we show two ratios that are equal to each other. So we see proportions a lot of times when it comes to different forms of art, when it comes to baking, when we're increasing or decreasing something in size and we want to make sure that everything is proportional, all of the ratios or the rates that we have stay the same. We use something called a proportion. So a good example is, like, let's say I was baking a batch of cookies and I needed so much flour. If I wanted to double that batch of cookies and I wanted them to taste the exact same as just if I was making one batch, I would have to make sure that I double all of the ingredients, that I make sure that proportional rate of doubling stays consistent throughout the recipe in order for the cookies to taste the same, if that makes sense. So today we're going to look at some examples that are just given to us with numbers. There's no word problems or scenarios that are related to them, just so that way you can see the method of, once we have a proportion set up, how we actually go about and solve it. So there are two methods that we are going to use. The first method is called crossroads, but you can think about it as the word rows, because we're going to look at the rows of numerators and denominators. The second method is called cross multiplying. So even though we disencourage you from using the X symbol to mean multiplication, the way we're going to kind of look at a proportion, it's going to kind of form an X, and we're going to use what's called cross multiplication to solve. So the first method I'm going to use is cross rows. So I'm going to be working in these two sections. So on your paper, if you want to pause the video and kind of set up these four problems, you can. I split my paper into 4 sections, and then up at the top, I just made a little kind of title section for each column, and then I wrote each 4 problems, 1 in each box. So you can take a moment to pause, set that up. Okay, so we're going to look at the first problem. So we have the proportion 4/8 is equivalent to x over 96. So remember, we can use a variable like x to represent something that we don't know. So you can kind of think about this as, like, these are two fractions that are supposed to be equivalent to each other, and they give us one fraction completely, but they only give us part of the second fraction. And we have to figure out, what does the numerator have to be in this fraction in order for these two fractions to be equivalent to each other? So in the crossroads method, what you're going to do is you're going to look across between your numerators and your denominators, and you're going to see if you can find some sort of increasing or decreasing factor. So if I look across from 4 to x, since x is the variable what I'm trying to solve for, there's no increasing or decreasing factor that I can find. But if I look at the denominators, I have 8 and 96. And if I think about increasing or decreasing factors, I'm kind of thinking about, well, how am I getting from 8 to 96? Is there something I am increasing or decreasing by? And with proportions, we always think about it in terms of multiplication or division. And so if I look at this row, I notice that to go from 8 to 96, what I'm doing is I'm multiplying by 12. 8 times 12 gets me 96. So in order to figure out what x is equal to, if I know 8 times 12 equals 96, and if I want these two proportions or fractions to be equal to each other, I'm going to do the same thing with the numerators. I'm going to do 4 times 12 to figure out what the value for x is. And 4 times 12 is equal to 48. So that means x is equal to 48 in this proportion. And all I did was look across my numerators and denominators across the rows in order to be able to calculate that value. Okay, so let's look at another example. I'm going to do the problem down here in the same column using the same method. I'm going to look across the rows or crossroads with my numerators and my denominators. In this case, I have a negative. So I have negative 10 over 5 is equal to x over 20. So if I use the Crossroads method, I am going to look across the rows, my numerators with each other and my denominators with each other. And I'm going to see, is there an increasing or decreasing factor? So to get from -10 to x, clearly there's no increasing or decreasing factor that I can identify. But if I look from 5 to 20, there is an increasing factor. To get from 5 to 20, I can just simply multiply by 4, because 5 times 4 is equivalent to 20. So if I keep that same increasing factor to the top row, I could do -10 times 4 in order to figure out what x is. -10 times 4 is -40, which means x is equal to -40. And all I did was look at the different rows. I looked at my numerators, I looked at my denominators, I found that increasing or decreasing factor, and then I simply multiply, or if it was the opposite, if we were dividing, I would divide by that factor. So this is how we use the Crossroads method. I would always check to see when you have a proportion set up, if you can just simply use the Crossroads method, because it's way easier. But sometimes when we look at Crossroads, there's not always going to be a very obvious increasing or decreasing factor. So the other method that we can use to solve proportions is something called cross multiplying. So when we have a proportion and when we look across the rows, if there is not a very obvious increasing or decreasing factor, what we can do is we can use this method called cross multiplying to set up an equation and use our properties of equality to solve for the missing variable. So for example, we have this proportion, 6/7 is equal to x/17.5. And you may be thinking, whoa, a decimal within a fraction, that's a little crazy. But remember, these are proportions. Like if a recipe calls like 6 cups of flour for 7 cups of sugar, we're trying to figure out if there's 17.5 cups of sugar, well, then how many cups of flour do we need in order to keep the recipe proportional? So it's okay that there's a decimal in there. I know it looks a little crazy, but if I look across rows, obviously from 6 to x, there's no increasing or decreasing factor. From 7 to 17.5, there's no obvious increasing or decreasing factor with multiplication or division, right? To get from 7 to 17.5, there's not an obvious number that I can think of off the top of my head that I can multiply 7 by to make 17.5. I can think of something I can add, but that's not how proportions work. We either increase or decrease with multiplication. So when we cross multiply, what we're going to do is we are going to look diagonally from numerator to denominator, and we are going to multiply across. So I am going to multiply 7 times x, and I am going to multiply 6 times 17.5. And I'm going to set up an equation where those two things are equal. So you can see it makes this x. So that can kind of help remember, like, I have to multiply. This looks very similar when you learn how to add and subtract fractions. The butterfly method you can use to simplify. So it's kind of a similar process, except we're setting up an equation from this. So if I cross multiply, I am going to write what I'm multiplying on either side of the equal sign. So 7 times x is what I'm going to represent on one side of the equal sign. And it doesn't matter which side of the equal sign I put it on, because they're equal to each other. So 7 times x, I would write that as 7x. And then on the other side, I'm going to figure out what 6 times 17.5 is equivalent to. So when I do my math, I'm going to get 7x equals 6 times 17.5 is 105. Okay. So now I just have one of those one-step equations that I can solve. So I'm trying to figure out what times 7 makes 105. And if it's not something I know off the top of my head, I can use the properties of equality to solve the equation. So since I am multiplying over here, the property of equality I want to use is the division property of equality, or depot property. So if I divide both sides of my equation by 7, I will solve that x is equal to whatever 105 divided by 7 is, and that is equal to 15. 7 goes into 105 15 times. So that means x is equal to 15. So if I went back and plugged in 15 to this proportion, these two fractions are equivalent to each other. 6 over 7 is equal to 15 over 17 and a half. Okay, so cross multiplication, what we're doing is we're multiplying across from numerators to denominators, setting up two sides of the equal sign, and then solving for x. Hi, everybody. Sorry about that. I have someone coming over to look at my freezer, and they just popped by. So in the last example, we're going to do another example of cross multiplication. So we have the proportion 15 over 12 is equal to x over 2. So we could actually use the Crossroads method to figure out what the increasing or decreasing factor is. Like to go from 12 to 2, we could divide by 6. However, if we do 15 divided by 6, we're not going to get, like, it's going to be some sort of decimal. So that means that x is going to be some form of either like an improper fraction or a decimal. So if you want to use the Crossroads method and just simply do 15 divided by 6 to figure out what x is equal to, you can do that. I'm going to use the cross multiplication method so you can see another example. So I am going to look across at my numerators and denominators and create my x kind of symbol. And then I'm going to set up my equation. So I have 12 times x, or 12x, is equal to, I'm going to keep the equivalent sign, 15 times 2. So if I simplify, I have 12x equals 30. 15 times 2 is 30. And then now I have this equation to solve. So something times 12, that makes 30. 12 times x equals 30. I can use, again, that depot property to solve. So I'm going to divide both sides of my equation by 12. And I get x is equal to 30 over 12. And if I simplify that fraction, I'm going to keep it as an improper fraction. So this simplifies, I could divide both of these by 6. This simplifies to 5 over 4. If you wanted to put that as a decimal, that would be 1.25 or 1 1/4. I'm just going to leave it as the improper fraction. So this is what x is equal to in this particular problem. So depending on the problem, if it's very obvious what the increasing or decreasing scale factor is, you can use the Crossroads method. If it's not so obvious, cross multiplication also works. Just don't forget your properties of equality when you're solving, because it's really important in order to be able to solve for the missing piece. And sometimes our answers might be a decimal or they might be an improper fraction, and that's okay. So in the next video, you guys are going to see some word problem examples about how we can look at a word problem and set up proportions like this, and then continue to go ahead and solve.